So let's see. I've already downloaded the data myself. I put it in, for me, I put it in C, temp, essay. Oh, you're on the screen? I gotta hit share again.
Zero visibility.
There we go. Yep. All right, so I've already, I had already started to kind of separate out the lab. So, okay. I downloaded the data. The data for the first part of the lab is, yep. The data for the first part of the lab is in Interp, and the data for the second part of the lab is in data. It's part 1 and part 2. So part 1 is the first part. Well, I don't know if it's not really the first part. One of the parts of the lab is for you to do a simple IDW calculation for a single point. You're not filling out a whole new grid. Okay, so this is as if this was the center of one raster cell. If you realize that basically it does this for every single point. You're going to determine the value of x using an IDW interpolation with the neighborhood defined by radius m. This is the radius right here. It doesn't matter what the radius is. Okay? It's all of these points. Okay? Right. You just need to know that m encompasses all these points. Okay? So go back to those slides, and you're going to use r as 2. That's the power 2. Okay? So you're going to figure out the weights for all of these points, but you now have 1, 2, 3, 4 points instead of just 3 points, and the values aren't in the hundreds anymore. They're 3, 5, 5, and 6. Okay? Otherwise, the math's going to be the same. Okay? So you're going to do 1 over 2 squared, 1 over 3 squared, 1 over 4 squared, and 1 over 4 squared. Those are going to be your raw weights. If you want to do it the first way that I was talking about, you basically add up all the weights, divide by all the weights, and then multiply each value by your adjusted weights, add them all up, and you're done. Okay. All right. The second part of that. What's that? Yeah, exactly. There's nothing on a computer. If that's what you're asking. Yeah. Okay, and then number 2, you're doing the same thing, but you're going to only use the 3 nearest neighbors. Which ones are the 3 nearest neighbors? Right. So not A. And you're going to change the r to 3. That's the exponent, the power. All right, so that's that. Okay, it's kind of the second part, but so you could do that in whatever order you want. So the other part of the lab is using this data from the book chapter, which is also one of the data sets that I was using as an example. I'm going to walk you through creating an XY theme. I did that already, but we'll do it again. And then we're going to select a soil pollution attribute, whichever one you want, and then learn about the various types of interpolation ArcGIS has to offer. Now, if you look at what to turn in here, what we're going to do is create a chart similar to Burl and McDonald's 5.5 table, which is this one actually. You're going to create a chart similar to this. So in your chart, we're going to have 4 columns. One's going to be the minimum value. The minimum value is the smallest value in the output raster. The maximum value is the highest value in the output raster. The percent area that's less than x, because I'm letting you choose the variable, I need to let you choose x. Because if I didn't, and I specified x, it would be a value that doesn't make sense because they all have different ranges. So your x should be in the middle of your values somewhere. So you've got a high and a low value. Pick a value in the middle. It could be if you want to come up with the mean value, you can actually calculate, right-click on the field that you choose. So if you choose calcium, you right-click on the calcium field and choose the mean for that field as your x. That'd probably make the most sense. But you don't have to choose that value as long as it's in your range. It needs to be between the minimum and the maximum value of the input points. Not the minimum maximum value in the output raster. It needs to be in the range. So make it interesting means make it a value that's in the range. Because if it's outside the value of the range, you're going to have a bunch that have a value of 0 or 100. Everything's going to be either in or out. All right. The last one is you're going to have the mean absolute difference from one of your IDW interpolators. Okay. So the IDW interpolator, the default IDW, which is power of 2, I forgot what the fix is. But we're going to walk through creating that default one and then doing one other interpolator compared to it. Okay? All right. So now for this lab, I only want the report. So when I say you should create an entire model, this time it's actually up to you if you want to do it as a model or not as a model. I think it works a little better to make it a model, and then you can run it multiple times. So a model that creates all the information that you want. So really, you're going to be able to create the minimum and the maximum value. That's just going to be part of your output. So when you run the Kriging interpolator, right? When you're done, that's already created the minimum and the maximum value. You don't need any additional processing steps to create that, correct? So that actually wouldn't be part of your model. But how would you calculate the percent? How would you be able to derive the percent area greater than x? Yes. What tool could you run that would basically give you that answer? A condition expression. Very good. Adam's correct. So you could create a simple model that had the input being the output. So for each time, you're going to have to run each of your interpolation algorithms. You're going to have to run. So you're going to basically create. Did I say how many? I did say somewhere how many you have to do. Is it 5? Where does it say that, Sarah? Yeah, 5. I want to see at least 5 interpolators. Okay. All right. So you're going to have 5 outputs. So if you create a model, you can take your 5 outputs of each of your interpolators. Those are your rows in your table, and then you could run them through this model that just had a conditional operator. Okay? So your conditional operator would have is it less than x? If it is, make it 1. If it's greater than x, make it 0. Once you run that, you can look at the output, the table and the output value, and it will allow you to, you just basically divide the ones by the total number of cells, and you'll get the percent. We can do that part. Okay, then the mean absolute difference from IDW. How could you get the mean absolute difference from the IDW one? Yeah. What's the absolute difference? If some of them are negative and some of them are positive, the absolute difference just means that I'm using absolute values. So basically I could do a formula for mean absolute difference, right? It's the average absolute difference from the surface. So we take the two surfaces, subtract them, come up with the absolute value, and then average all the pixels together. The average for all the pixels. You could do that, I'll give you a hint, you could do that through a zonal sum, where there's just one zone. It's the whole thing. Right? So let's walk through creating those, and if you want, you can put those into a model. I think it would be faster to run it as a model, but I'm going to go through each step for you right now. So the first thing that we need to do is to create. I'm gonna restart this up. Okay. First thing we need to do is create the data set that we're going to use. So maybe if I went a little bit too fast before, what we want to do, actually, I'm going to close this up altogether. I do have a starter MXD that you can just double click on. So the starter MXD has a few of the data sets in it. I'll explain why I included those data sets here really quickly. Once it comes up. One of them is called the land mask. I included the land mask. Why do you think I included it? Anybody know? It's going to be like the zone that matters. You're going to calculate the mean absolute difference within the land area. So this is the area that matters. We only have points inside this area. It doesn't make sense to include this area because, first of all, it's not even on the land, and these are samples that were taken on land. Second of all, they're outside, they're extrapolated values. So this is the data set you're going to use to calculate the land mass. Okay. Okay. So this is it. I'm going to turn off. Oh, it's actually the land mask 2 that is the one that you're going to use. Not the land. The land mask was is the stuff that's not water, or the stuff that is water. The land mask is 2 is the one you're going to use. Did it not show up? You got it? Did you download the data? Okay. Did you unzip it? It's inside the notes folder. Oh, you just added the data? Well, that's all right. That's fine. You don't need to do anything else. You could change it, that one, turn off. This is the one that you don't need to use the interp.mxd if you don't want to. Okay. So we have that. The next thing we're going to do is add the point data. That's us in the soil pollution.dbf. So go to the same place that you got the rest of the data from and add soil pollution.dbf. This data set contains the soil pollution data. Here's all of the, you can do any of these values, cadmium, mercury, lead, zinc. You can even do organic matter if you want. You can do one of those though. Okay? So I'll pick lead. That sounds scary. Okay. If I right-clicked here, this is what I'm talking about. And I went to statistics. So for lead, the mean is 160.79. So I could use that as my X value. I'm just going to write it right here. I'm just going to round it off to 160 since it doesn't really matter. What's the range? The min and the max? The min is 37, the max is 364. So 160 falls within that, and it falls kind of close to the middle. So that's fine. 160, that's the value I'm going to use for X. Okay? You can choose a different value, but make sure that it falls within the range and probably well within the range. Otherwise, you're not going to get interesting results because sometimes all of your data is, if you choose 363, sometimes almost all your data will be below. If you choose 38, sometimes it'll always be. That's what I mean. You're going to choose a value here close to the middle. All right? Okay, that's what I meant. So let's manually create some of these interpolation outputs. Yeah. So I right-clicked on lead, and I said statistics, and it has the minimum and the maximum. Oops. You're right. I just didn't get it. I wrote it. I mean, I didn't write the right number. 664, right? 54. What? 654. That's an easy number. You think I would get it? 654. All right. It's my, yeah. All right. I've never been real good at, can't spell it all. But sometimes you read shapes instead of reading individual letters and numbers. All right. So, so we've got the data set, and we're going to, the next thing we're going to do is take soil pollution and turn it into a shape file or just an event layer. Either one will work for now. So you right-click on soil pollution and you say display XY data. Displaying XY data, we need the easting to be the X value and the northing to be the Y value. You'll know if you get these wrong because your points won't show up on top of the study area. So easting and northing, you don't, for this part of the lab, I didn't give these a projection, so you don't need to give those a projection. You could, it would be best practices to import, if you knew you were going to use it with other data, to import from the landmass data set. But like I said, I didn't assign it, so it says unknown, same as before. But if you were actually doing this out there in the real world, and you knew you were going to use it with other data, and you knew it matched that other data already, it would be best to assign it a coordinate projection. All right, so now I'm just going to hit OK, and I'll get my points. So here are my points. There's the study area. I've got a couple outside the study area. That's okay, because they're just going to help the interpolation. Okay? Now, these are just virtual points at this point. They don't exist anywhere on disk. If I save this document again, they'll still be there every time I open it back up, but it's just recreating them virtually. That's also fine for this particular part of the lab. They don't have to be actual points. To use them in geostatistical, It looks like they must be, unless maybe, you know, I messed up and didn't turn the extension on. See if that was a problem. Yeah, that was the problem. So it wasn't what I thought it was. Let's see if you can use virtual points. I'm getting off track here. Yes, it looks like you can choose those values as, oh, that's actually the soil pollution data set. That's not, oh, there's the events. Okay. Okay. So this will work there too. I could have done it in class. Getting back to what we're doing right now. All right, so the next thing that we're going to do, now that we have all these points, is to use the spatial analyst tools and do a couple different interpolations. We're going to explore our data using the spatial analyst tools. So go under interpolation, and the first thing that I want everybody to run is an IDW of the soil pollution data using all the defaults. So choose the soil pollution events and leave everything else the same. 12 points, all that stuff. The only thing that you should change if you want to change, and I want to change it, is the output cell size. But you can leave that the same. You can leave that a constant if you want to, too. So you right-click on the soil pollution and say add display XY data. Did you get to this window? And then choose easting and northing and say OK. You got that now? Okay. So go back to IDW. Choose those points you just created, and then choose where you want to save it. I want to save it in Lab 8. I'm gonna create a new folder just called Outputs. I'm gonna save it in there. Oh, I gotta say the name of it. I'm gonna call this IDW_default. Now remember, it has to be less than 13 characters or 10 characters. That might not work, unless you call it a TIFF. Then it'll work, no matter what. Okay, so go to customize extensions and choose spatial analyst. Well, they don't conflict with each other. Okay. All right, so under Z value, you need to specify which which surface you're interpolating. I'm interpolating lead, I said. So I need to choose lead. So now it will interpolate lead for me. Like the slides in the PowerPoint, I chose zinc. So now I'm choosing lead. I want to change the output cell size to be a nice normal number. You don't have to do that, it's optional. But leave it the same. And make sure it's always the same. It probably will be, but it should always be the same. Don't choose a different value for different data set, for different interpolation. So whatever you choose here should always be the same. You choose a constant cell size. I chose 5. Leave the power and the variable, all the rest of it the same. So basically, we're gonna be saying we're gonna use the 12 nearest points. 12 nearest points, power of 2. We can change this to fixed, and then it's a distance. And that distance is whatever units you're at. All right. Does anybody want to me to leave this up for a few more seconds, or? Okay. I'll do that then. Anybody have any questions about what individual values mean here? Actually, that is a good idea. So, did I say that in the lab somewhere? No? Yeah, everybody does, right? See these 2 points? Yeah, everybody's got those. Yeah, do you have a question? What does it say that's different? Oh, okay. Well, does anybody else say something different? You're in geostats, spatial analysis. It looks like there's a different default in geostatistical analysis than spatial analysis. Okay, so Ashley asked, it was you, right? You asked, should we, under environments, choose the landmass 2, the raster data set, to be the default? To affect the output. You can either do it now or you could do it later. I actually think it would be more neat and clean to do it now. Although I didn't think about that until she brought that up. But if you go under environments and choose if you go under raster analysis and choose the cell size as the landmass 2, and choose the mask as landmass 2, then it will only include those areas and won't even try to interpolate. It only choose those areas within landmass 2 as an output. And then when you go to do the subtraction, you don't have to do anything else. You could also change the snap raster to be the same, landmass 2. So now, finally, you could change extent to landmass 2. Well, it won't really matter, but at that point. So now it will already be a raster of the same size and dimension. It'll be 10 instead of 5, but that's okay. In fact, we might want to change this to 10 because of that. 10 will allow it to run faster anyway, so maybe that's a better value too. Okay? So I changed this to 10, and under environments, I changed the snap raster, I changed the extent, I changed the cell size, and I changed the mask there. Anybody have any? Yeah, the snap is under processing extent. Exactly. The snap raster is different than the processing extent in that the snap raster will cause the edges of the cells to be exactly in the same location, rather than off by just a little teeny bit. Yes. I chose the same thing for everything. I mastered it. All right, now I'm going to hit OK here. Okay? So when this is done, I got an error. Did everybody else get an error? Well, that's not good. Anybody else get an error? Everybody else has worked? With the events? Yeah. So if you keep getting an error, this is okay. Mine worked the second time through. That's fine. If you keep getting an error, the thing that you can do is right-click on the events and say Data, Export Data, and save them. I don't know why that error comes up when you have events. It's like it doesn't always read them right. So what you could do is just create a new shapefile and save it into that same location. ctemp lab 8. I'm just going to put it in interp. I'm going to call this data points. And hit save. And at that point, what you can do is delete the events layer. And then the other one, since it's a permanent data on disk, it won't have that problem of not drawing right. So, all right, does most everybody's look like this? So go into your processing results, and then open it, and click on that one. So did you the environments right there? Processing, and there's the whole thing's under raster analysis. The whole thing's under. Yep. Mask is the same layer. So you can change this one and then change the other two. Change the other two under processing. So this is probably trying. So this is trying to save it.
Am I supposed to be on the
probably didn't choose the right variable. Okay. Choose one of these folders. Right now, you're just in the folder one. Now it's like, okay, so go to geoprocessing results. So you're using the object ID. That's what I meant by you used the wrong field. And lead or whatever you want to use. I've been using lead. Choose something else. All right, so we got lead up there. So the reason that yours looked like it was going up is because the numbers here were 1s and then 2s and then 3s. Like the object IDs were related to your X field. I mean, related to the X variable or the Y variable. Okay. So this layer is going to be like your comparison layer. You can put this, we will put this one in our data set, in our table. We will put this one in our table, but the mean difference, we don't have to bother calculating the mean difference between this one and this one because the mean difference will be 0. Does that make sense? So this layer right here is going to be the layer from which we calculate the mean difference to all the other layers. Okay? So it's there. So before we go any further, let's calculate one more IDW. What I'm going to do is go under geoprocessing results and choose to modify these values a little bit or a lot. So I'm going to choose that layer that I'm going to refer to that other layer that I created because the events layer wasn't always drawing like I wanted to. Always keep zinc. Lead or whatever you chose. Don't change that. Okay, that needs to stay the same. But I'm going to change the IDW. I'm going to change this to be. I'm going to change this to just be the 3 nearest. So I'm going to leave this on variable, but I'm going to make it just the 3 nearest cells. So now it's just going to be the 3 nearest points. Sorry. So I'm going to change this. I'm going to call it IDW underscore 3. Now, the advantage to running the IDW out of here, out of the results, is that I don't have to change the environments anymore. The environments are already changed. It's just going to rerun it using the same environments. But if you go back and double click down there, which you will do because you have to do one spline and one preview at least anyway, then you'll have to re-specify the environments down there to get it to work right. Okay, so now I'm going to hit OK. So once I do that, now I have two. I have my IDW underscore 3, and I have my IDW where it did the 12 nearest. Look at the minimum and the maximum values. I can actually right click on here and say properties and find under source. Yeah, it's under source. I have the minimum and maximum values right here. See, 37, 60, 653.8. That's my minimum and maximum values. I can go ahead and put those values in the table. Those are the values that I want on the table. These would be the values for IDW default. Now, I want to find the number, the percentage of values that are less than X, which we decided was 160. How do I find the percentage of values that are less than 160? I already told you. That's the second one. First one's going to be oh no, you're right. That's the first one. It is a conditional statement. Never mind. Second one's going to be zonal stats. Okay. First one, conditional statement. All right, so let's run a conditional statement under map algebra and say, so the conditional statement will just be a conditional statement, and it will be, does IDW default, is it less than 160? Use the same value each time, and if it is, it's going to have a value of 1. If it's not, it's going to have a value of 0. So I'm running a simple conditional statement. Now the advantage here is you no longer really have to use the environments button because you already did it before, so the extent is already right, the cell size is already right, it won't change anything. Okay? That's why I think it was a good idea that you had to do it back up there. So once this runs through, now I have the 1 are areas that are below X. We want the percentage areas below X. So if you look at the attribute table, how can I figure out the percentage of the area below X? From the attribute table. How do I figure out the percentage of areas below X? Anybody? I think it was a field calculator, but there's only 2 numbers. Yeah. So which numbers do I divide by which numbers to get which numbers here? I want to get the percentage below X.
So ones are below X.
1s are below X.
You need the total count.
So I need to add these 2 together to get the total count. Right. That's the total number of cells. Right. Yep. And that goes as the third column. The first column is the min. Second column is the max. Third column is the percentage of values below X. And the final column is the difference, the mean difference from IDW. So let's calculate that. Turn this off for a second. This is the data set I'm talking about. You need the mean difference from the default IDW. So what we're going to do is first find the difference between this one and this one. In fact, we could just go ahead and find the absolute difference, right? In raster calculator, there's a way to do that. I'll just show you. Raster calculator. We take the function here is called ABS. And we're going to take the difference between this one and that one. Does it matter which order I put these 2 in? Mine does that too.
If it wasn't yours, now it's mine.
If it's subtraction, where you put it matters, right? But what does absolute value do?
Make it positive.
Yes.
Not my bad.
So, in this case, even though it's subtraction, it normally would matter, but in this case it does not. So you can have either way. You're going to get a positive difference if it's. I mean, you're going to always get a positive difference. Right? So I'm gonna go ahead and run this, and again, you don't need to set the environments. You don't need to set the environments now because it's already kind of set. Now, isn't this kind of interesting? You can see the difference between those two data sets. The black areas mean that there is less difference between the data sets. The white areas are the areas of greatest difference between those two different interpolation algorithms. So the biggest difference is a value of 124. The lowest difference is very, very similar. All right, so we actually could use zonal statistics, but I do think the mean is reported. So if you go under source, for this data set, you could look at the mean right here. That's the value that you want to put in your table. That's the fourth value. So you have 4 columns, min, max, the percentage below x, which is 160, and the mean absolute difference, which is this value. If you wanted to calculate that automatically, you could do zonal statistics. This is what I was talking about. I'll go ahead and demonstrate that real quick. So I could go under zonal, and I could say zonal statistics as table, and simply choose the difference raster, which is, which one is it? 23. Choose the difference raster. Why doesn't it show up here? Oh, sorry. The zone data has to be the land mask, and the difference raster is the zone data. The value data. So now when I calculate this, I'll get that same number. I should get that same number. Let's look. As the mean. 19.73. If it's not the exact same, it's really, really close. You're not using what? Oh, okay. Okay, so 17 is the value. You need a less than that. Because what you're doing there is, what you're doing there was saying, if the IEW set is true, so in other words, it's not 0. That's why. All right, so I've walked through one row in the table. In fact, 2 rows in the table. Because one row, the mean value is going to be 0. The difference, you don't even have to calculate it because it's going to be 0. So you can do this, you could just do this in Excel. So I have all the values that I need. Why isn't Excel coming up? New blank workbook. So Interpolator is going to be here. Interpolation method, something like that, whatever you want to call it. Say the min, max, percent less than 160, and mean absolute difference, mad, from IDW default. Something like that. So this one would be the one that's 19. Okay. This is going to be IDW fixed, or sorry, variable 3. And then I would pull out the min, the max from here. then the percent would, we didn't actually calculate the percent, did we? We just talked about it. So we'd take this value right here, and take this value right here, equals this divided by the sum. Okay. So that's that, and I can express it as a percent by hitting the little percent button somewhere, right? There it is. Maybe give it a few. So that's one row in the table. Now for your ID, it actually probably be best if you put your IDW default first. Oops. And just wrote 0 here. So then you'll have a min and a max, and a percent less than 160. You can figure these out, but this will be 0. So you need to have your IDW default and 5 additional ones that you test against the IDW default. So your table will look, it looks kind of like this, except for we have minimum max, and we have percent area, but we have less than a number, and they have greater than a number. And then we also have that other, the difference from IDW. So you're going to do this kind of table. We've already created one line together, and you can make a model if you think it helps you, but you don't have to. You're not turning that part in. What you are going to do is to make a small report, about a paragraph, okay, on things that you should talk about. Note where differences are large and small. For example, are they near the river or particular flood class? That's why you have the flood class data. Are they at a particular elevation? There is elevation in the data set if you want to create elevation data set to look at that. So you should include one screen capture for each layer. Probably just either the mean differences or just the straight up predicted surface. Okay? So illustrating your report. How do you do screen captures? You can hit Shift Print Screen. There's also this snipping tool. Anybody used this before? Okay, so this is how the snipping tool works. You just, once the snipping tool is open, let me get back to it. Then, let me close this. Go back to snipping tool. You just say new, and then you draw a box, and then that's on your clipboard. You can copy any part of your screen doing that. If you want, you could right-click and export it to a graphic. I mean, not right-click. Go up to File, Export it to a graphic, and then import it in. I just think this is faster for quick reports. All right, and so you're going to hand the report electronically. I forgot, or didn't forget. I just forgot to update it. You're gonna upload it, not email it to me. Okay. All right. You don't need to turn in a model. No model for that part. And then do this. That's pretty straightforward. The next part of the lab is it's a lot more like a normal cookbook style lab. And so I just want you to go through and follow it through using the geostatistical wizard. And this is really more for your information and helping you explore the geostatistical analyst extension. So we're not going to go through that together as class. There's a couple of thinking questions at the end to answer and turn in. But other than that, yeah, we're at a point where you can can go through it, and if you have any questions, just let me know. The maximum value is 16. So what I said was to choose something that's well within the range. If you choose something really close to the edge, sometimes you're just going to get 1 to 0. So I chose the mean, choose something in the range that's well within the range, not next to it. So I'm going to go stop this video. I'm going to stop the video and